derivative,
Integrals.
differentials.
Hello guys, welcome to Multivariable section 12.3 Vector and Acceleration. Today's lesson is taught by Ray and Alan. Yay! So this chapter is not difficult. So now, since we have already learned some basic concepts about vector, for this chapter, it's just how to apply the concept of vector into our real physics world. And there are just several key formulas and concepts you have to memorize to know about. If you learn AP Physics C, this chapter will be extremely easy for you. If we have a vector value function RT, which equals xti plus ytj, where xt represents the function of the motion along the x-axis, where yt represents the function of the motion along y-axis, we can just simply use derivative to find the velocity vector and acceleration vector functions, which represented in the image you see right now. So the velocity vector will just be r prime t, which is x prime ti plus y prime tj, and acceleration, which is equals to at, which is r double prime t equals x double prime ti plus y double prime tj. And the speed, since speed is just a positive number, so we just use the absolute value to calculate that, which will equals to the square root of x prime t squared plus y prime t squared. And if you are calculating the motion along a space curve, which is a three-dimensional thing, it's really simple as well. You just add one more function value to it. So now the position vector function will just be rt equals xti plus ytj plus ztk, and the velocity and acceleration and speed will be the same.
Hey guys, we're gonna do a practice problem. Actually very simple, you should be able to do this. So we have r of t. This is a position function. Do sine t over 2i to cosine t over 2j. So this is a position function, and velocity is pretty much the derivative of that. So if you want to have v of t, take derivative of the first function one by one. So derivative of sine cosine t over 2i, and the 2 in front and the 1 over 2 will have cancelled out each other. Minus sine t over 2j. So that's pretty much basic derivative. And then I'm going to calculate speed. So pretty much speed is the derivative. No, I mean absolute value, because speed is always positive. So you're taking the absolute value of r prime of t. So we're taking the absolute value of v of t. So that equals square root of cosine t then square t over 2 plus square t over 2. And you see there's no I and j because we're just taking the value of these. And actually it's 1 because cosine square theta plus sine square theta equals 1. Okay. Acceleration is the same thing. A of t is the second derivative of r. That gives us this. And the rest of the chapter is pretty much the same. For different shapes, for example, circle, ellipses, you have different forms of position function. The idea is always the same, that take derivatives.
Same thing. If you have a function of acceleration, which in this case is at equals j plus 2k, you can use integration to get the velocity function as well as the position function. So in this case, vt will just equals to integral of acceleration function and equals to a plus 2k dt and you've already learned how to do the integration for vector function. Same thing for the position function RT, it will just be the integral of Vt equals to and that's where you get the position function. Always remember to add the plus c at the end of each equation. Okay, so the last concept we have to learn in this chapter is called projectile motion. This is more like a physics thing. You have to simulate the motion of an object in both y direction and x direction. So the first thing we have to know is for the motion in the x-axis direction, the function is v0 cosine theta e, and in the y direction it will just be negative half gt squared plus sine theta t plus h, which in this case theta is the angle. Theta will just be the angle how you shoot the projectile, and v0 is your initial velocity right here, and g is the acceleration of the earth, which we all know, which is 9.8, and t will just be the time, and h will be the initial height. So once you know these two formulas, you just need to convert those into a vector function, and the vector function for a projectile will just be RT equals v0 cosine theta times t I plus h plus v0 sine theta t minus half gt squared j.
Thanks for watching, guys.
And we'll attach a note sheet under the video, and I think it can help you to review this section and just like a math cheat sheet, you know what I mean.